Well, I guess you
Okay.
did.
Once again, the Towers of Hanoi puzzle. Um, I just wrote it for fun because I thought it would be a good Rolang example, and I thought I'd show you. The idea is you have to take these three discs or whatever number height of discs you have and move them from the left peg to the right peg, but you can never put a larger disc onto a smaller disc. So you have to use the middle one as an intermediate place to put it. Okay, so uh, and I got this from a Pascal example
Prologue
here, which
example.
is prologue. I'm sorry, Pascal, um, and implemented in um, uh, Rolang. Okay, so the first thing we have is we have three tower. I select the towers uh, operation, which loads the code in here, which I can modify if I want. And I put the height in here. So for a height of 3, if we explore this, we'll see that it moves left to the right, the left to the center. So now it's uncovered the biggest disk. Now it moves from the right to the center, so it uncovers the right disk, the right peg, and then it moves the left to the right, which puts the big disk on the bottom, and then I move the center to the left, the center.
The center to the right, and then the left to the right. You're done.
Left to the right. So this moves it. I mean, we can see it more clearly if I put in 2, we explore. It moves the top one to the center, which uncovers the big one, and then I move the top, the big disk from the bottom all the way over to the right, and then I move the one from the center to the right, stack them up. Okay,
Can it do 4?
we can do any number. 4, explore, takes a little longer. Okay, and we can see how long it takes the more I add it. If I put in 5, take a little bit longer. Okay, so uh, okay, what the interface does is it matches the name height with the value 5. So the name height is going to be 5 for this run. Okay, and then I create some new channels, new unforgeable names. Um, Result is where I'm going to get the output from. Standard out goes to the log, and that's a power box function that um, binds the name standard out to row IO standard out. Okay, I'm going to create a move contract that's going to do the moving and an acknowledgement contract to know when it's done. It'll send me an acknowledgement that says I'm done. And I'm creating a log contract also to create a log in order. And that will keep a list of the moves for me to print out at the end. Okay, and then I just describe the problem. Um, and uh, then I call the move contract with the height, which is now 5. And I move it from the left to the right using the center as a holding peg. And I get an acknowledgement back when it's done. Okay, everything happens in parallel in Rolang. So you have to, in order to know when something is done, you have to have some kind of acknowledgement or have some kind of output on the channel. Okay, then I call the contract move. Okay, here I'm sending it this pattern of 1, 2, 3, 4, 5 arguments. And here I make a contract, which is really a read of 5 arguments. Okay, height, where we're moving from, where we're moving to, what we're using as a holding peg, and the acknowledgement we return when we're done. Okay, now within here, I have to sequence the operations. So I create another acknowledgement channel, which I'm going to use inside the move operation to keep things in order. Like I said, everything happens at once if we don't order it in Rolang. Okay, so if the height is 1, well, and I want to go from and to, I just move the from to the to. Okay, and I send that to log, and I also send that to the.
It's working now, hopefully.
Okay, and but if the height is more than 1, I have to uncover the disk on the from, the smaller disk on the from, and move it to the other, the holding disk, before, when that's done, then I can move the from, which is now a larger disk, to the to. Okay, and when that is done, okay, so here we moved 1 off, so the height is -1. Now here we say height 1 because we know the disk is uncovered. We want to move it directly. So we move the from to the to, other, height of 1. We ignore the other disks. When that's done, then again with the height -1, so instead of 5, it's 4. We move the other one, the one that we saved on the other peg, to the to peg, and we're done. Okay, we moved a peg from the from to the to. And then when that's done, we send an acknowledgement back to say that we've completed the move. Okay, and this is recursive in that each move is really 3 moves here, moving 1 out of the way, moving the smaller one out of the way, moving the larger one to where we're going, and then moving the smaller one back on top of it. Okay, and then the only other thing I have is that I put these on the log. Now, if I just wrote these to the result directly, okay, like result, I can spell result, and let me do fewer. Let me do 2, see if it'll screw up on 2. Okay, what we'll see, top disk from left to center, top disk from left to right, top disk from center to right. Okay, well that worked. But if I go to 3, I think it won't work because these will print out in the wrong order. Okay, every time I write to, what? It's still writing to log. How come it's writing to log? ULT. explore. Move top disk from left to right. And then it got an error here. But in any case, it didn't work. What normally happens is I would get, and I guess it's having a problem with it's getting an error on the when it tries to print the list at the end, I guess. But I should have 3. But oh well. Okay. In any case, when I write all these to result, the order I'm going to get them is non-deterministic. They could come in any order. So if I put log here, then it goes to the log. And each time I log a term to the list, it concatenates it with the prior list. So it initializes the list. And this is not the latest copy. I don't know why not. List is empty initially. And then I have the log. When log receives a term in an act, it reads the list into prior, and then it concatenates the prior with the new term. So it builds a list of all the outputs. And then when I'm all done, I read the act back from the first move, initial move, and then I read the list in from the list channel, and then I send to result the list. And that's what we see here, this list, which is in the right order. Okay, any questions?
Yeah, I think I actually kind of followed some of that.
Yeah.
Yeah,
So one thing that kind of triggered my thoughts was when you said that Rolang operates in parallel. And is it that acknowledge thing that is that the I don't know, the right vernacular, the right element that kind of you have to acknowledge something in order for it to know what, because it's running in parallel, it to know what where it's functioning, whatever.
Right, you have to explicitly make the order of actions, or they come up non-deterministically. You don't know what it's going to do when, because it's doing everything at the same time
Okay.
in parallel.
and if it goes non-deterministically, it'll break the rule of putting a larger one on a smaller, won't it?
Yes, it'll break the rule.
So are there
lists in the right order?
other languages that function in parallel like that?
Yes, let me share my screen. I want to show y'all something in regards to Daryl's question. I can't share. There we go. Okay, I'm going to share my screen now. This is a site called Rosetta Code. And here's the Towers of Hanoi problem.
That's what I was thinking of.
And here's all the different programs that it's been written in. And for example, I would look at the C program. It's this line of code right here. I think the C is a little bit easier to follow than the Rolang, but C doesn't have the problem of being concurrent by default. But anyway, you know, there's all those different programs, and they all do basically the same thing.
Are they all sequential languages? I guess they are.
Yeah, nearly all of them are sequential languages. I don't know. OCaml, yeah, I guess it is too, even. But we ought to put, you know, the pi calculus and Rolang in that Rosetta code, just just because we can. I don't know how to do it, but anyway, yes, good question, Daryl.
So all those in that list are sequential languages. There's like, what other parallel languages are there then?
What did you say? There's Rosetta. Let's look at that.
RosettaCode.org.
Oh, there's a
Where's
language.
Rosetta? Rosetta is parallel, right?
No, that's the name of the site.
What?
That's the name of the site, Rosetta Code.
Oh, okay. Rosetta's.
I'm looking for a concurrent language like Pict. It's not in here.
I don't know if you remember, initially the virtual machine we were going to use for Rolang was Rosetta because it's a parallel.
Oh, yes. Rosette,
right.
yeah. But anyway, no, I don't see any parallel languages in there.
I didn't know there's a language called Brain F *****.
Brain fuck, yeah. That's kind of a famous what do you call it? Oh, I don't even know. But it's kind of like it builds up the way you build up Lisp. Here's they don't have Lisp in there. Isn't that weird? Maybe they have what's the other name? New Lisp. See, that's not bad. Anyway, okay, I'll stop sharing.
Well, I think we should definitely get Roland on that list.
Yeah, and pi calculus, because I want to show you one other thing. Oh. I lost my ability to share my screen again.
Well, you're sharing your Discord right now. I'm looking at a Discord conversation.
Oh, am I?
Yeah.
How do I get back to? I would see what I would like to see is let's go over here to Greg's where he calls it a one-line translation scheme for translating tree-like data structures into flat parallel storage, such that the data can be reassembled back into its original state. Okay. I call it deserializing a linked list. Am I wrong saying it that way? But see, I would like to see this over on that Rosetta Code site. And then I would also like to see the pi calculus version of the same thing, because that's what Greg was talking about, how this compares to Milner's pi calculus. But anyway, so much for that.
Yeah, I would like to see that actually, the Rolang version rather than the RoCalc version. You showed that also, and that made more sense to me. I can't really follow.
Yeah, here's the row calculus version.
Yeah.
But I thought this is the Rolang version, right?
Right.
And tell me the difference between RoCalc and Rolang.
Well, I forget exactly, but
yeah.
Basically you're doing, the right is the same with the exclamation point.
But would this wouldn't work in Rolang? So this is more like a pseudocode here?
Yeah, that's not Rolang.
Okay. Well, he says it's Rolang.
I think it's RoCalc. He does have Rolang.
Well, look what he says up here. He says, what is this? And then, well, this guy says, is this scholar or math? And Greg says it's Rolang. But does he mean RoCalc? Or is he talking about this part?
Well, there's Rolang below, right?
Oh, okay.
So he has the Rolang there, but the two-line version doesn't. It's RoCalc. It's not Rolang.
Okay.
And can you interpret the RoCalc, Raphael? Looks like he's not.
What? What did you ask?
Can you interpret the RoCalc that Greg put up in that?
I would have to check again the dice and drain code. It's
Why
this.
don't you show it again?
The one he explained.
This one right here is the one we're talking about.
Oh yes, this is kind of hard to read. So the other example on the
Rolang is easy to understand, but I think
Yep.
that's RoCalc is harder.
Here's the Rolang here.
Yeah, this one I get it. It's a loop with an accumulator. So I have code that highly resemble this.
Okay.
In RChain token, we have few iterations like this one.
But yeah, okay. I'm gonna stop sharing. I'm gonna go over that Rosetta code site and see if they have anything. What would that be called? Converting a linked list into a deserializing linked list.
Maybe I can talk quickly about the development on my side.
Yes.
Okay, so let's get this. Okay.
I don't know.
Okay.
Is it?
So
link list and get back the original list.
So I'm preparing for the only lacking feature for DAPI to launch. So DAPI of course needs RChain to be ready and to have the hard fork done. But we also have one feature that is not yet possible with RChain token, which is the renewal and the expiration mechanism. So right now with RChain token, you can do NFT or FT. And so let's just consider NFT here. Let's say you have an NFT that is cat 12. There is no system in which, as the deployer of the NFT contract, for example, the name of the contract might be cat. There is no way to have a kind of renewal and subscription mechanism. So basically, if someone has cat 12, he has it forever, except if he sends it to someone or sells it to someone. So you cannot integrate a subscription mechanism, which means that lots of online web services that work with subscriptions and regular payments cannot be reflected in this RChain token. So DAPI, of course, is one of them because in DAPI there is a name system and we have a yearly renewal mechanism, just like the DNS. So right now we were stuck and we cannot do that. So with the DAPI, we need something like this. After 12 months, cat. So if a NFT has not been renewed, goes back to like a default, or it is confiscated. So basically, the owner lose the property of a NFT after a given period if he has not renewed and paid this a fee. So the first thing is that it's very so it's not the Roland does not deal with months or years, so it's all timestamps. So you have, I think there is a minimum. Let me check. So when you deploy a contract, you can have this expires property. It can be nil, which means that there is no expiration, or it can be a timestamp. And it has to be minimum 2 hours because the dates on the blockchain are never thin because one node and the other nodes may have different dates. So you have to give an expires property that is superior to 2 hours. And if you do that, it means that after 2 hours, basically a purse, in the case of NFT, a purse is just like a NFT. So after 2 hours, someone will be able to delete this purse if it has not been renewed. And this is where the check is done. So it's quite easy to read. If enough time has elapsed, then this NFT can be kind of destroyed, which means that when it's destroyed, someone will be able to mint it just after it has been destroyed. So if you own Amazon in the DAPI name system, if the owner has forgot to renew it, basically and if you want to get it, you just delete this expired purse and then you purchase it. So this is how it works. And so this is the first step. It works, it's coded. And the second one is the action of renewing a NFT. And this is the part I have not coded yet. But basically, we have an interesting like challenge, which is to make sure that the renewal occurs in the late period of the subscription. So if you have a 12 months period, we want to avoid someone renewing the first month. So let's say you purchase it 1st of January. So we don't want you to be able to add one full year like the 3rd of January. So you have to wait for like a late period, and the way it will work is that you can only renew in the last 1/10 of the period, which means that for a yearly mechanism, you can only renew in the last month and few days. This way, we make sure that you cannot renew in advance for like 20 years. So you have to do it at each like end of the period. And of course, if you have a 10 hours period, you are only able to renew in the last 1 hour among the 10. So this is how it will work, and this is very cool because it's not only useful for DAPI. I guess we'll have many other like services that will use this feature, because it's just a subscription system with a fixed price for the subscription, and the owner of the contract can always change this subscription price over time as well. It's not a fixed setting. So that's it.
So if I'm understanding what you just demonstrated, is this essentially kind of a workaround as to the fact that you can't mint NFTs till after the hard fork?
No, this is all this is all post hard fork stuff. So nothing will be deployed before hard fork.
Okay, so this is more or less then, if I'm understanding right, a NFT as a subscription.
Exactly. So let's say you have a newspaper on the web, you will be able to express the subscription with these options on the NFT contract.
I see.
So the originator of the contract has to own these things that he's selling subscription to, right?
Yeah, you deploy a NFT contract, and you will either create some NFTs and send them to people, or you will let people mint NFTs.
Okay.
In the DAPI system, for example, when you register a name, you're just minting a new NFT.
Okay.
So I missed that one part. Now you got the time from the timestamp of the block.
Yep. Yes, I forgot. So this is the most important. I could have presented it earlier. So yeah, I'm taking this data, and let's say where I use this channel. So when you create a purse, for example, I get the timestamp from the block data, and this gets set as a property of the purse, and we probably have other places. So this is where when you delete the purse, we check the current timestamp against the one in the purse. So here, I think it is the purchase operation. So when you purchase an NFT, okay, 45, we set also the timestamp. So this is the initial timestamp when you purchase this NFT. And so yeah, we use this block data channel in 3 places.
And you said the granularity there was 2 hours?
No, so apparently I asked Nadziper and Tomislav. So this timestamp that you may receive is validated by the network, which means that if you receive a block with which means that a miner cannot, when he issues a block, when he proposes, he has to give it a timestamp that is correct in the order of 5 minutes. So you can't cheat very much. So this is the granularity I was talking about, I guess. And for example, you can issue a block right now and pretend like you pretend like it's 7:50 and in fact it is 7:53 or something like that, PM. So this is why there is this 2-hour minimum subscription period, but I don't know I don't know any applications with a 2 hours subscription system. It's a bit strange, but yeah, Of course, it works better over a long period of times, like 1 month or a few weeks.
So it's the subscription is going to be multiples of 2 hours.
Yes, often it will be very much superior to 2 hours. So we won't have any issue. Yep, and so yes, this channel is quite handy to. So we have other informations in this block data you can retrieve. So this is block height and also sender. I think it's the public key. So if you have other rolling applications and you wish to play with time or to integrate the last block into your rolling execution, you can do it this way by getting data from block data channel. So in our case, we only need timestamp.
Okay. Let me just show that quickly. This is the block data, and we read that, and we get the block number, timestamp, and sender. So I do it for localhost. I get block number 135. And you know, I guess that's the seconds since the epoch, whatever.
No, it's milliseconds from a
Really?
Unix time, I guess.
Milliseconds. So if I do that for mainnet, I get block number 0.
What's that?
That's interesting.
Maybe it only works with deploy and not explore deploy. This is logical.
Yeah, I'm wondering why it seemed to work for localhost on Explorer.
Oh, okay. Yes.
Oh, now I did a deploy on mainnet. It's going to take forever. I do a Control A, Control C. Let me try it on robot. What's wrong with this? Control A, Control V. Okay. So if I do it on robot, what do I get? It gives me a block number. Now, if I deploy on robot or on localhost, explore, I get block number 135, and I do a deploy, and I should get the same thing. It just takes a minute. That's interesting. Let's see if this returned anything yet. Still going on mainnet. Oh, no data at deploy ID. That's weird. Standard out is I have as a result. So it's going to, oh, I know. There's no data at deployer ID because I didn't specify row colon was it row colon RChain? Deploy ID. Oh, I explored again. Silly me. Deploy. That should be quicker. Of course, this is going to not give any result because I didn't send it to deploy ID.
It's time for Mr. Lighthouse's neighborhood.
That's a good one.
Okay, so now I got block number for localhost. I got the same block number, 137. I don't know. Interesting. I don't know why mainnet does. Oh, I should try testnet.
Okay, so let's switch to the debrief, I guess.
Okay.
All right, it's time. Later, guys. Bye bye.